Hey there, friends. Welcome to my channel. My name is Ryan Schul. I talk about all kinds of data science topics, machine learning, deep learning, artificial intelligence, and so on and so forth. So for today's lesson, I want to talk about analyzing hotel staffing needs. And at the end, I'm going to create an interactive app that we can play around with and fine tune and interact with. And it's going to show us the outcome of the analysis that we're doing today. So why would we even want to analyze staffing needs? I did another video, a little bit similar, kind of different, about staffing for a bank branch. So the genesis for this whole conversation was a couple of years ago. I worked for a bank, and one guy that I worked with had a spreadsheet, or not one spreadsheet. I think it was like an Excel file with 67 or 68 different tabs, and he tried to predict what is going to be the staffing for the bank's branches all across the United States. It's a big bank. I won't name any names, but it's a major bank, and he tried to predict how many people need to be at the bank. And I looked at the problem and I said, well, you can probably do this in a couple of lines of Python code. Why do you need 68 tabs on Microsoft Excel workbook to do this? And he said, well, that's how we do it. That's how we do it. So on and so forth. But I mean, you can do that if you want to. It's going to drive you nuts. It's going to drive your boss insane. And it's going to create a lot of headaches and unnecessary ulcers. Okay, let's just say that. Let's just make it easy and straightforward and simplified using Python. You don't need an Excel file with 68 different tabs to understand your staffing needs. That was for a bank branch. This is a very similar exercise, but we're going to look at a hotel this time, okay? Instead of a bank, it's going to be a hotel. And why do we need to do this? Are you overstaffed or understaffed? That can be a big problem, right? If you're overstaffed, people are sitting around with nothing to do. You're wasting your money as the enterprise owner, right? And people are bored. They're kind of tired and bored, and they don't even want to necessarily be doing that. You want to keep people engaged. You want to keep people involved. You want to keep people like up to speed on things, right? You don't want your staff to be angry or disassociated, right? You want to keep them engaged constantly. Respond to patterns and seasonality of the business, right? Fridays in July are not the same as Mondays in February. Very different concept, very different engineering, right? So you have to understand these patterns and cater to that. And again, you want your customers to be satisfied too. If I walk into a bank or a hotel, I want service pretty quickly, right? The customer has to be happy. You have to satisfy the customer, and you have to keep your staff happy too, right? Otherwise, there's going to be turnover, and people are going to leave, and then you have to retrain, and it's going to be there's going to be an impact on the cost, right? So housekeeping, guest, front end, back end, you have to take care of all these things, right? So let's get into it. Let me import the data. I have hotel bookings. This came from this website. I'll give you the link at the end. I just downloaded this data sample over here. I use a lot of data from Kaggle. It's pretty useful, pretty interesting. I think they have some good stuff over there, so I tend to use a lot of that. Sorry, I've been sick. Been sick recently. Been sick for couple of years now, actually. Like, I'm not really getting better, but that's fine. That's fine. So we're going to look at the data, and if the booking is canceled, if that is equal to 0, then it's not true, right? So these types of things tend to be binary. A 1 is true, and the booking is canceled, so a person is not coming to the hotel. That the booking is not canceled, that's a 0, right? So the person is coming to the hotel. So anything that's not canceled, that's what we're going to look at. So we have to filter out the non-canceled, because think about it, all the time people make airline bookings, hotel bookings, Airbnb, even like Zipcar. I used to use Zipcar, and don't use that anymore. People make reservations and they cancel it, right? So we don't care about cancels. We care just about the people that are using a service. So if canceled equals 0, that is what we're going to focus on, because that's true. These are the bookings that we're looking at, okay? So let me import the data. Right here, we'll take a look at this, and we'll see how things shake out right here. So here's the data. It's canceled 0, no, so that's true. So all these bookings are coming through, and we have adults, how many adults, how many children, babies, country, and things like this. We have deposit type and reservation status and the reservation status date. Okay, so just the basic information is coming through. We're going to go ahead and create some buckets right here. So when we bucket or bin the data, I've got a video about this, we are assigning the data to different columns or different like buckets based on when people check in. So 12 p.m., 1 p.m., 2, 3, 4, 5, 6. That's when people typically check in. And you can have before, you can have after. That's kind of unusual. But normally people will check in to the hotel between 12 and 6 p.m. There can be some outliers, but I can focus on that. That's a different type of exercise. You can have people checking into the hotel at 1 a.m. in the morning or midnight. That's not too common, so I'm not going to focus on that. Okay, let me run the next cell here and then try to determine how many staff are needed based on the reservation status, date, the day of the week, and the month of the year. So again, this is very seasonal. So maybe there's a lot of bookings close to Thanksgiving. People are going to see family. They don't stay with the family. They stay at a hotel close to their family. Maybe you're on Christmas. You're traveling for Christmas. Maybe 4th of July, big holidays, you see a lot of travel. And let me think, like February 28th, is that a holiday in the United States? I don't think so. I don't think there's going to be a lot of bookings. I don't think there's going to be a lot of travel February 28th. But you get close to July 4th, November 28th, or Thanksgiving, December 25th. These things are seasonal, right? So you have to look at it with a seasonal perspective. You have to have that lens. Are people going to be doing more bookings, at this point in time? Or is there going to be fewer, right? Because we're trying to determine the staffing needs and handle the clients, right? And handle staff as well. That's what we're doing here. So let me refresh this now. So we're preparing the analysis based on the hour, the day of the week, and then the month of the year, okay? And trying to determine the total staff needed, okay? And we're getting the staff sum over here and the day sample, and then the average staff. So the staff sum is the total count, the total summation of all the staff that we need. But the average staff can be rolling on, it can be off throughout the day. So the average is always going to be less than the total, right? Okay. Oh, hopefully that makes sense. So let me refresh this and we can see here, based on the aggregation, all the data, everything that we've consumed and analyzed and presented up to this point, August is definitely the busiest travel season. I worked on Wall Street for 20 years. I've seen August, everybody's gone. They go to the beach. Like I work in New York City. So August is a big time. Like maybe if you're in South Florida, it's a little bit different. Maybe South Carolina or California or whatever, maybe different. Maybe Washington State. If you're in Seattle, maybe that's a little bit different. But based on the data, this is what I'm seeing here. So I'm in New York. I think this totally makes sense to me. And July is big for travel, right? Around July 4th. May, you have Memorial Day. October, people are taking some time off. The least travel time is actually December. Okay, so we're looking at this with focus on rainbow colors, right? That's why I got this graph, and just looking at different staffing needs for the hotel throughout the year. Okay, so let me go ahead and refresh this chart, and we're going to look at the day of the week, the hour, and the month throughout the entire year. So I think this is probably easily the most interesting chart in the whole presentation here. So you can see 3 p.m. as the darkest color. Darker corresponds to higher counts or higher frequencies. So 3 p.m. across the board, most people check in. Down here, depending on the month and depending on the day of the week, you have darker or lighter colors, right? So 6 p.m. on a Monday, not too many people are checking in. All you need is 1.9 staff. Obviously, you won't have the 1.9. You round up, you get 2 staff working at that time. Here you need 3, 5, 6, 3 p.m. Sorry, the cat is interfering here. Can you please move? I want to do a little showcase of your face there. Okay, that's my cat. So based on this right here, you can see during the time of the day, and I only cut it out from 12 to 6. If you have overnight checkers at 3 a.m., people are checking in. I doubt that is a big problem. I think you need 1 staff for that. They can handle it pretty easily. And how many people can one person check into a hotel at a time? Maybe it takes takes a few minutes, right? Like I've been through the process before, 10, 12 minutes, maybe 15. It doesn't take more than 20 minutes to check in. So if you have one person coming at 3 o'clock in the morning, all you need is one person checking in to your hotel, right? One staff person checking into your hotel. Like if it's a bigger hotel, and again, it's based on the data that we analyze. So in all my videos, I try to make it representative of the data, right? But you have to change the model slightly, presumably, to your changing data. So if your data is different, the output of the model is going to be different. I'm trying to just align the inputs with the outputs and make this very flexible and very scalable, so you can input your own data and get the same outcome very easily. Maybe make a couple of tiny changes, maybe make no changes whatsoever. I'm trying to make this usable and scalable so people can understand it and acclimate to that pretty easily, right? So that's the whole point here. So you can see 3 p.m. is the most common check-in for every single month, okay, across every single day. You have Monday through Sunday here, so I think this graph is pretty representative of what the staffing need is visually, right? And I'm going to go ahead and build a baseline case here. Okay, let me get a little water. And then based on the hour of the day and the day of the week and the month, we have the output here. What is the staff needed to handle this hotel, right? Again, based on the data. Now, maybe you have a big hotel, maybe you have a small hotel, and the number is going to be slightly different, but the concept is exactly the same, right? Like if you have a bigger hotel, you might have more staff handling the demand. If you have a small hotel where, I don't know, like 1 or 2 people check in per day, like your staffing needs is much lower. But this is just generally how this would work. And they set up a little function with the inputs here that you can predict based on what the model already was trained and tested on and made predictions on. If you have a Friday, November, 3 p.m., you need a staff of 6, right, to satisfy the customer demand. If you have like 12 p.m., let me change this to 12 p.m., right, instead of 6, you need 2 people to check in. And if this is, remember, August was bigger, right? August was the biggest month. So over here, August was the biggest. Okay, so if you change to that and you change this, we know that 3 p.m. is higher demand for check-ins, right? And Control Enter to run the cell. Now you need 8 people to staff up the hotel, right? You need 8 people for check-ins. And then based on this right here, we can look at a few different scenarios based on the day order and the hour, right? The check-in. Again, we're just looking from 12 to 6 p.m. And it could be after, it could be earlier, but that's kind of unusual based on the analysis that we did. You see again, what is the sum of the staff needed? 3 p.m. comes up over and over and over, right? And Sundays is pretty busy. Saturdays is not so busy. Mondays is probably pretty dead. You only need 6 staff over here, and you need almost double over here, 10.125. So there's no 0.125 staff, that doesn't exist, but maybe 10 people over here and 6 people over here on a Monday in February. Okay, and then I created one more example down here where we can actually take the model that we just trained and just tested and create an application that we can interact with these features. Okay, so I just took everything that I just created right here. So this is the baseline to CSV. So this is the baseline model. Baseline is just everything exposed, everything is open, everything is done. If I do a Control F baseline, you can see over here. Okay, so this is what the model has been trained and tested on, and we're going to take that and export that to a CSV. I'm going to put that on my desktop because you have to save the data somewhere, or you have to have a server. I don't have a server. My laptop is actually a server. It's not like a real server, but if you have a laptop and it's always on, that can be a server. You'd probably put the results on the server and retrain the model. Occasionally, it doesn't have to be daily. This is not daily frequency. This is probably monthly frequency that you would have to update it. But you would update the model with new information, save it, and save the output to somewhere. I'm saving it here. I'm going to go ahead and copy and paste that into another file that I created Let me minimize this a little bit. Go over here, and I have staffing application. Okay, and that is over here. So I'm going to close that. Put everything I just pasted into here. Control C, Control V to paste it. And I'm going to save that. Okay, I'm going to save this file right now. Save and close it. And then I can go ahead and run the app from here using Streamlit and Python. Okay, so I create everything in Python. Obviously, all my models are in Python. I can put this over here. I think it's actually already running. I tested this just before I started the video. Let me create a new instance. So go over here, and then Anaconda. Okay, and here's my whole channel. You can see all the links over there. It's kind of cool. Link. So this is starting up, and I'm going to run this application. So this is how you create an app for anybody to use it, right? So what I was demonstrating before was just the interactive notebook, the Jupyter notebook. How do we create the model, train test it, and run the model? This is how anybody can run it, right? So you'd have an instance right here called staffing app.py, and it'll give you all this code. I'm going to give you every single line of code right here so you can see how this works. Okay, and based on this, you would copy paste it into right here, from here to here, paste it into a text file, and then run it using a Jupyter notebook. And I'm going to run this instance right now. So this is starting up. I can put this over here. So separate instance. And still starting up. It takes a few seconds. But once this is done, you can run this on any kind of server, any kind of machine that you want, and you can make it accessible to a phone too. You can make it so people can download the app onto a phone and run it on your phone. So here's the day of the week. I'm gonna say Monday and 12 p.m. What's the check-in time? What's the staffing? We need 3 people, and I'm going to show the heat map over here. We need 3 people on a Monday in April. Okay, and all we need is these 3 variables. So you have the day of the week, the month of the year, and the time of the day. That's all you need, and you can get the results. We need 3 people. Here's the staffing needs. Okay, again, 3 p.m. comes up. That's very common. It's very frequent. People check in around 3 p.m., a little bit before, a little bit after. If you go to, let's say, a Thursday and August, I remember August was a big one, right? And you check in at 3 p.m. Now it's not 3 over here. Now you need 7, okay? So you need a staff of 7. And if you go later in the day, it's going to be a little bit different. Click on that. Now you just need 2 staff. So most of the people are either checking in or they're not even going to your hotel whatsoever, right? They're not traveling. They don't care about your hotel. But if people are going to see you at your place of business, 3 p.m. is the busiest, a little bit before, a little bit after, and that's it. Once you get past that hump, then things slow down a lot, right? And if you go to another month, what was the least? I think December was the least. Let me go down to December. December at 6 p.m. you only need 2 people, and if we go up to 3 p.m., remember that was the busiest. Now you need 5 people. So that's it, guys. That's how you create an application to do staffing for hospitality. We're looking at a hotel, but again, I tried to make these examples very representative, very accurate, very precise, and very relevant to any kind of data source. So you can change a couple inputs, your outputs will change. You could maybe just take this and plug this into your hotel right now. If you work for Hilton, if you work for Marriott, if you work for any hotel, I think this is relevant. And other businesses too, like retail. If you work for Starbucks, how many people are going to Starbucks? You need the data to consume the data and do the analysis. And I'll bet in Starbucks, it's not 3 p.m. It's a big peak. That's for checking into hotels. It's probably earlier in the morning, maybe 6, 7, 8, 9 o'clock is the peak. Maybe you have like a lunch bump or something like that in the afternoon. But you would just have to take the concept and use your data, plug that in, and then solve the problem. That's what this video is about, like solving an abstract problem using realistic data and doing something that's relevant, right? But it really depends on your specific scenario, what the output is going to be. So that's it. So I'm going to wrap it up. Thanks for your time today. Hopefully this is interesting and informative. And I'll see you in the next video. Bye, guys.